Hello everyone, my name is Purab Singh. I am pursuing MTech from DVIPS. Currently I am in 8th semester. I am going to give you an introduction about an algorithm, longest common subsequence. It is a dynamic algorithm, so have a look on it. Longest common subsequence. LCS is the problem of finding the longest common subsequence to all sequences in a set of sequences. It's a before understanding longest common subsequence, we have to understand the meaning of subsequence. Subsequence is a set of characters. It is a string that consists of characters. Suppose here BDCA is a subsequence where BDCA are its characters. Subsequences start from left to right. So we have to find the longest and common subsequences. Suppose this is another second subsequence, so we have to find the longest common subsequence between these two subsequences. So we have to so the longest common subsequence between these two subsequences will be PC, because PC is common in these two subsequences. Generally we deal with two sequences in longest common subsequences. Here is a diagram for better understanding of longest common subsequence algorithm or problem. It is YJ elements or subsequence 1, or this is XI element, or we can say subsequences 2, subsequence 2. So what are our inputs in longest common subsequence? There are two strings or two subsequences, and we have to generate or we have to produce an output, the longest common subsequences between these two subsequences. Suppose here is an example ACTGAACT dash dash and TGACTC dash dash dash. So we have to find the longest common subsequences between two subsequences. So what is the longest common subsequences between these two subsequences? It would be TGACTC, TGAACTC, sorry, TGACTCGCAC is a subsequence which is common between these two sequences. It's a basic rule: if a subsequence ends with the same symbol S, then the LCS will also end with the symbol S. The uses of LCS, longest common subsequence, is a classical computer science approach problem. It is used in data comparisons of programs, used in bioinformatics in a widely, it has a wide use in bioinformatics. It is also used by revision controls of systems such as Git, because it works on a previous result and generates a new results by understanding the previous results, which is the concept of longest common subsequence. Here is the optimal substructure of longest common subsequence theorem. Let x is equals to x1 x2 dash dash to xm, and y is equals to y1 y2 dash dash to yn. These are two of our subsequences. First is x and second is subsequence y, and the z is our longest common subsequence between these two subsequences. For these two subsequences, so the first point of algorithm or optimal substructure is if the last element of subsequence x, which is xn, and the last element of subsequence y, which is ym, is equal, then the last element of our longest common subsequence will also equal to xm equals to yn, and zk minus 1 is an LCS of xm minus 1 and yn minus 1. And the second point states that if xm is not equals to yn, if the last element of subsequences are didn't match, then zk is also not equals to xm implies that zk is an LCS of xm minus 1 and y. If xm not equals to yn, then zk not equals to yn implies that z is an LCS of x and yn minus 1. Sequences x1 to xn and sequences yn to ym. The length of the longest common subsequences of x1 to xi and y1 to yj is represented by the LCS of ij. Here a condition arises if xi is equals to yj, xi element is equals to yj element, then the LCS of ij is equals to LCS of I minus 1 or LCS of I minus 1 j minus 1 plus 1. The value of LCS of I minus 1 j minus 1 will be incremented by 1, and this value is assigned to the new LCS of ij. And if the xi element didn't match with yj element, then we will take the maximum value from these two subsequences values. First is LCS of I minus 1 j and second is LCS of I j minus 1. The maximum LCS value will be taken by LCS of ij if xi is not equals to yj. Here xi and yj cannot both be in LCS. So we have discussed these two main points of LCS. So what's the running complexity, running time of longest common subsequence? The running time of longest common subsequence is depend on the number of character or elements of subsequences. M into n. M is the elements of first subsequence and n is the element of second subsequences. Recursion of length. Here are three conditions for recursion of length. First is if I is equals to 0, j is equals to 0, then we assign 0 to over c of ij. The second condition states that if ij is greater than 0 and xi element is equals to yj element, then we will increment the value of c of I minus 1, j minus 1 by 1 and assign this value to c of ij. And in the third condition, if ij is greater than 0 and xi is not equals to yj, then we will take the maximum from xi j minus 1 and c of I minus 1 j, and the maximum value will assign to c of ij. This is the recursion of length. Now we are understanding the algorithm of longest common subsequence. LCS length xy. Length of x is denoted by m and length of y is denoted by n. For the value of I from 1 to m, we are assigning 0 from 0 to c I, any value of I or 0. And for j 0 to n, we are assigning 0 to c 0 to j. And for value of I from 1 to m and the value of j from 1 to n, we are checking the condition if ij is equals to yj. If this condition fulfills, then we are incrementing the value of c I minus 1, j minus 1 by 1 and assigning this value to c of ij. And we are also assigning an arrow and a lightly tilt to b of ij. Else if this condition c of ij doesn't match with xi doesn't match with yj, then we are checking is c of I minus 1 j is greater than or equal to c of I j minus 1. If this condition satisfied, then we are putting the value of c I minus 1 j to over c of ij and assigning an arrow in upward direction to b of ij. Else we are assigning the value Cij minus 1 to C of ij and assigning the arrow in a horizontal direction pointing to those value from which we had taken the value of C of ij and assigning it to B of ij and returning the value, returning C and B. So it's an algorithm of longest common subsequence. Let's have a look on the example of longest common subsequence. This is yj values and this is our first subsequence PDCA, and this is the xi values BABCB. It is our second subsequence. So we are putting 0 in this row and 0 in this column by our recursion for length. If I equals to 0 or j equals to 0, we have to put in a 0 in our C of ij. So we are putting 0. Now we are going for the xi equals to yj or not. So let's start with a is equals to b in this condition. No, a is not equals to b. So then what we'll do is not equals to b, a equals to b. Then what we are checking if C of I minus 1j is equals to or greater than C of ij minus 1. Then we are assigning the value of C I minus 1j to a C of ij with an upward arrow. So we are assigning an upward arrow in the value of this block to our LCS C of ij. Same we are doing for this block because A is not equals to B, and same for this AC, A and C. A is not equals to C. Then we are checking is A is equals to A. Yes, and this condition A is equals to A. Then we are incrementing the value of C of I minus 1 and J minus 1, which is the value of this block, with 1, and assigning a tilt arrow in the direction which is pointing to this block and assigning the value 1 to it. Now we are going for checking for the value of is B is equals to B, this B is again is equals to B. So we are incrementing the value of this block, which is C of I minus 1 and J minus 1 with 1, and assigning an arrow in the direction of this block. Then we are checking is B is equals to D. No, B is not equals to D. Then we are checking the condition. In this condition, this element is greater than this. So it is our else condition where C of ij minus 1 values will be assigned to C of ij with the horizontal arrow. So we are putting horizontal arrow there and assigning the maximum values between these two blocks, which is this. So we are assigning 1 there. Same we are doing for B is not equals to C, B is, and all rest element. After completing this structure with appropriate values and arrows, it's our complete longest common subsequence diagram. To find an LCS, we have to follow the arrows. For each diagonal's arrows, there is a member of the LCS. So this is the longest common subsequence algorithm for finding longest common subsequence between two subsequences. Hope you enjoyed this video. Thank you. If you have any doubt regarding longest common subsequence, you can contact me at my Gmail ID, which is purabsen@gmail.com, or Facebook/purabsen, or Twitter purab/purab22. Thank you for giving your precious time.